Hey guys, in this video we're going to be making an avoid obstacle program for our robots. It's going to work very similarly to our line read because it's going to be using IR sensors just like that program did. But this one will be using the front IR sensors as opposed to the bottom IR sensors. And these IR sensors are labeled A0, A1, and A2. So first thing we always need to do, include a library. And for this program, I'm going to put a delay at the very beginning so a robot doesn't take off on us as soon as we start it. And I'm also going to turn on our motors. Alright, coming down into our loop. The first variable I'm going to make is an unsigned int, which means that it is an integer or a whole number and it must be positive. And it's going to be called sensor offset, and I'm going to set it equal to 50. So this next line of code is going to have a lot going on and it's going to be a lot to unpack, but let's go through it and see if we can figure out what's going on. Okay, this line of code has a new function that we haven't looked at yet, and it's called sensor calibration. Now what this function is doing is it's calibrating your sensor. And what we're doing is we're subtracting the sensor offset variable that we made earlier to create our desired sensitivity for how close we want our robot to get to something before it makes a decision. So I'm just going to make a comment creating desired sensitivity for our robot IR sensors. And we're going to want to go ahead and do that again for our other two IR sensors as well. So I'm going to go ahead and copy and paste, and all we've got to do is put a 1 here and a 2 here. And we also need to change these numbers here. And this next part is optional, but it's the way Rokit has decided to initialize the robot's LED light array. So if you would like to have your LED light array changing lights, then you initialize it by doing this. ddrc equals 0xff semicolon. Okay, next we want to create variables for our sensor values. It's going to work very similarly to digital read from the line read program, except this time we're going to be using analog read, and it looks like this. So the A0 IR sensor is our left sensor. So basically we're just setting this value equal to the analog read of that sensor. Now the difference between digital read and analog read is digital read returns high or low, while analog read returns a number between 0 and 1023. So digital read is great when you're trying to read if something is white or black, or a brighter color or a darker color, because you can get that high or low return value. And analog read is better for this sense because we can see exactly how close or far away an object is to our robot as we're driving by it. And that's why we created this sensor offset as well, to create a sensitivity for our robot. Because as we get closer to an object, our analog read for our IR sensor is going to get lower and lower until an object is pretty much touching the sensor, then it'll be at 0. But as it gets farther away, it'll get closer to that 1023 value. So what this offset is doing is just allowing us to make a decision at a certain point of an object getting close to our robot. So we've got to make 2 more of these for our 2 other sensors. So same thing, change this to 1, and this, and this to 2. And the reason we're using unsigned int for all these variables is because these sensors can't read negative values. So as we see here, analog read returns a number between 0 and 1023. So the numbers cannot go negative, or this analog read won't work. So we want all of our variables to be unsigned int for that reason. Okay, so that's all the setup we need for this. Now we can move down into our condition statements. So we're going to say if our left sensor value, oh, I forgot something. Alright, so we actually have to come back up here, and this is going to be the center sensor value, and this is going to be the right sensor value. Sorry about that. Okay, back down into our condition. We're going to have if our left sensor value is less than select level A0, then we want to back away from that object. We're going to go ahead and make a noise to indicate that we have sensed something and we're backing up. Also, for our LED light array, to light our robot up in a way that shows that there's an object on our left, we're going to type this. So just to unpack this a bit more, this left sensor value, the closer you get to an object, the lower that number is going to get. So once that number gets lower than our selected sensitivity, we want our robot to do something about it, because we don't want to run into an object. We want our robot to back away from that object. So once this value is less than this value, we want to run this block of code, which says go in reverse away from the object and turn, make a noise, and light up the robot. So we're going to go ahead and code something very similar for our center and right sensor values. Okay, same idea here for our right sensor. The closer it gets to an object, the lower that this right sensor value is going to get. And once we get close enough that it's lower than our selected level, we want our robot to make a decision and back away from the object, make a noise, and shine its lights on the right side to indicate that there's an object on that side. And we're going to go ahead and do the same thing for the center sensor value as well. Hey guys, this is Sean from the future here. For the buzz function, I wrote 913, 0. That is a typo. It should read 913, 12. So sorry about that, but I did not catch it until after the recording. Okay, same idea here. As our center sensor gets closer to an object, the number is going to continuously go down. Once it's lower than our selected level, we want our robot to back away, make a noise, and light up. And our last possible case, if our robot doesn't see anything and all of our sensors are good and they're greater than our selected level values, then we want our robot to just drive straight until it sees something. And our default lighting is going to be this one here, which is the same as our center sensor. So I'm going to go ahead and copy and paste it here. Alright, and that's how we create a avoid obstacle program. I'll see you guys in the next one.